Inside the shadow of Geneva, under the world's floor, lies a shock of human resourcefulness and a normal harbinger of annihilation. The beast known as the Large Hadron Collider, LHC. It is a manual of smart evaluation, permitting scientists to investigate the subatomic generally, and prompting the disclosure of the baffling God molecule, the Higgs boson. Right now, as of now, prestigious physicist Brian Cox has made a chilling declaration that sent wonder waves throughout the philosophical community. Something concerning has been examined at CERN, something that might have accomplished expanded ways beyond our comprehension. Has our essential objective for illuminating and enlightening assortment set us on a collision course with catastrophe, obliging us as we plunge into the pit of this clear problem? However, sooner than we sway into the assertion, what sizable atom gas pedals the gigantic Hadron Collider? The LHC, worked by utilizing CERN, is a 17-meter ring of superconducting magnets and the field's most vital and, by all means, silliest solid atom crush. It watches out for the apex of human logical achievement. The truth of the circumstance is solid to the point that it can reiterate the true conditions of the universe's creation. Yet should this design intend to open the insider assessments of the universe, it may lead to something far more significant and alarming. CERN, laid out in 1954, is one of the world's most important, prestigious assessment associations, with 23 member states and a vast network of specialists. It is a center for joint exertion and development. The LHC is CERN's central project. However, it's only one part of a colossal network of gas pedals and spikes. This tune is for subatomic particles and their journey towards existence itself. The LHC speeds up protons to nearly the speed of light, sending them on a guide course that mirrors the energy of the universe at the time of the Big Bang. The effects create temperatures 1,000,000 times hotter than the center of the sun. A massive array of magnets guides the protons on their journey, while impressive cooling structures safeguard the magnets at temperatures colder than space. These contain 1,232 dipole magnets, which guide the beams, and 392 quadrupole magnets, which focus the beams just before impact. Another prominent type of magnet is used to press the particles close together to extend the possibilities of impacts. The task of CERN is to impact, like joining two needles 6 meters apart, with such precision that they meet. The accuracy required is astonishing. The LHC's design is a marvel of organizing. It is set exceedingly close, with the same support points that distort, hidden away 574 feet underground, protected from the field's radiation. On this underground level, the entire system is cooled to a temperature of 46 degrees Fahrenheit, colder than the vacuum of space itself. This cool environment is necessary for the superconducting magnets to work optimally. The support centers in the LHC are made to crash at 4 regions across the gas pedal ring, appearing distinctly in relation to the areas of 4 atom markers: Atlas, CMS, ALICE, and LHCb. Each fulfills an essential need in researching special pieces of particle material science. Collectively, they pass through epic cameras, capturing portrayals of these impacts. Specialists then sift through the data, searching for signs of the elusive Higgs boson, otherwise known as the God molecule, an extraordinary eccentricity sign to the universe's fundamental arrangement. It's like trying to solve a boundless jigsaw puzzle, one where the pieces are dark, and the picture is nearly impossible to interpret. By focusing on the microcosm, we gain pieces of mastery into the universe. However, with each response comes another question, and with each discovery, another check. The LHC isn't merely a vigilant instrument. It's a symbol of human ambition, development, and a testament to our chosen journey for knowledge and our longing to figure out the fundamental forces that shape our universe. However, as we stretch the boundaries of what we understand, we must also remember the moral and existential questions that arise. What are the risks of looking at the hidden world? Should our quest for understanding unexpectedly open forces we have zero control over? Inside the hallowed passageways of CERN, where the focal points of human understanding are continually pushed, a revelation has emerged that sends a chill down the spine of even the most experienced scientists. Brian Cox, a former researcher at CERN and a voice of authority in the field of particle physics, recently made a statement that has left the scientific community both enthralled and stunned. Cox's words resonate with a terrifying possibility. The goal of CERN's Giant Particle Collider is to replicate a mini Big Bang. Yes, you heard that right, a smaller-than-expected version of the very event that gave birth to our universe. The physicist also discussed the potential consequences of this goal, highlighting the LHC's remarkable ability to open the insider realities of the Higgs boson, and also the assessment of dark matter, a substance that makes up a significant portion of the universe. Imagine the opportunity to unlock the very essence of the universe. It's an exciting gateway, yet one loaded with risks. The mini Big Bang isn't just a theoretical idea. It is a genuine possibility inside the LHC. The temperatures, the pressures, and the energy all replicate the conditions of the universe's creation, much like continuing from the earliest critical moment of cosmic history. However, with such strength comes a genuine responsibility, and the questions become ever more pressing. Consider a situation where something goes wrong, something similar to an incident that occurred back in 1978. The Russian physicist Anat Borsky experienced a calamity that could have easily ended his life. In 1978, Borsky was working at the U.S. synchrotron, part of the connection for high-power particle physics. A breakdown caused his head to enter the event trajectory for a proton beam. The beam entered through his skull, exiting through the back of his head and nose. Borsky's sight changed dramatically. He saw a flash brighter than 1,000 suns, yet he had no immediate symptoms. Despite the severe tissue damage and bone destruction, he remained alert and even walked to the treatment center for care. The resulting injuries were severe, causing tissue death and partial loss of hearing. But Borsky ultimately survived and continued his scientific work. This incident wasn't a simple accident. It's a cautionary tale about the immense power and potential danger of particle accelerators. The risks of a particle accelerator like the LHC should not be taken lightly. The potential for extraordinary reactions, the manipulation of the fabric of reality, and the creation of forces beyond our understanding are not the stuff of science fiction. The very real dangers of this work, especially with the potential to create miniature black holes or other exotic phenomena, could have unforeseen consequences. The possibility of producing tiny black holes, regions of spacetime where gravity is so intense that not even light can escape, is particularly concerning. The creation of such entities, even on a small scale, could lead to a catastrophe. While scientists at CERN have assured that any black hole produced would evaporate almost instantly, the idea of manipulating forces beyond our control is unsettling. These theoretical calculations suggest that any such black holes would pose no danger to Earth or its inhabitants, but the sheer scale of these experiments warrants careful attention. As experts push the boundaries of our understanding, it's crucial that they do so with full awareness of the potential risks and ethical considerations involved. The journey for knowledge has always been accompanied by risk, but as we venture into new frontiers, we must remain vigilant and transparent. The LHC is a testament to human ingenuity and the pursuit of knowledge, but under its grand exterior lies a space of immense intellectual inquiry filled with potential dangers and moral implications. The studies conducted within the confines of the collider harness energies and forces beyond the comprehension of most, and though we may uncover the fundamental building blocks of the universe, we must tread carefully, understanding the immense responsibilities that come with such profound discoveries. The energies involved in these collisions can produce conditions similar to those that existed in the earliest moments of the universe, allowing scientists to test the fundamental building blocks of matter and investigate the very fabric of spacetime itself. However, with such immense powers comes the undeniable potential for unforeseen consequences. The creation of miniature black holes, exotic particles, or other phenomena that could destabilize the surrounding environment remains a pressing concern, even though theoretical calculations suggest that any black holes created would dissipate quickly. Despite these assurances, the idea of opening the door to forces we cannot yet fully comprehend still stirs anxiety. The LHC operates at the frontier of scientific exploration, and its experiments are not without risks. Even with rigorous safety protocols in place, the potential for accidents or unexpected outcomes cannot be entirely eliminated. These dangers are real, not just theoretical. The impact of these discoveries, whether positive or negative, could reverberate far beyond the lab and into the very structure of the universe itself. The ethical questions surrounding the LHC's experiments are equally significant. As we seek to unlock the secrets of the cosmos, we must carefully consider the potential moral implications of our actions. Is it responsible to push the boundaries of knowledge so far, knowing the risks involved? How can we balance the pursuit of understanding with the responsibility to safeguard life on Earth and the stability of the universe? These are questions that must be asked and answered by both scientists and the broader global community. As we delve deeper into the mysteries of the universe, we should remain mindful of the extraordinary power we wield. The LHC represents the pinnacle of human scientific achievement, a tool capable of revealing truths about the origins of the cosmos and the forces that govern it. But with this power comes a tremendous responsibility. Scientists must continue to approach their work with the utmost caution and transparency, ensuring that their pursuit of knowledge is done in a way that minimizes risks and maximizes the potential benefits to humanity. Ultimately, the future of the LHC and its discoveries depends not only on scientific breakthroughs but also on our ability to navigate the moral and existential questions that arise. As we continue to probe the deepest recesses of space-time and explore the fundamental forces that shape our universe, we must remain vigilant in recognizing the potential dangers and uncertainties that accompany these endeavors. The pursuit of knowledge is a noble goal, but it is one that must be undertaken with a full understanding of the risks and a commitment to using our newfound understanding responsibly. In conclusion, while the LHC represents an incredible leap forward in our understanding of the universe, it also serves as a reminder of the immense power of science and the profound responsibility we have to wield that power wisely. The road ahead is filled with both incredible opportunities and significant risks. The questions raised by the LHC's experiments are not just about what we can learn, but about how we choose to use that knowledge. As humanity stands at the crossroads of scientific discovery and ethical responsibility, the choices we make today will shape the future of our world, and perhaps even the universe, tomorrow.